So let's look at the properties that hold for dot products. We've got to be careful here, just like we had to be careful when we looked at vector arithmetic, because even though the dot product is very like multiplication, it is not the same thing. And we will see here that there are some things that are different about standard multiplication between numbers and about the dot product between two vectors. Okay, so some of these will look familiar. We have commutativity. U dot v, v dot u, it's the same thing. It doesn't matter which vector comes first in a dot product. We have distributivity. We can distribute either from the right side or we can distribute from the left side. It works. Okay. This one's a little different because we got a couple of products going on with vectors. With numbers, there's only one multiplication, the multiplication that we're familiar with. But with vectors, we have scalar vector multiplication, and now we have the dot product between vectors. So it turns out that they work together pretty well. It doesn't matter if I do the dot product first and then multiply by a scalar, or if I multiply by a scalar first. And it actually doesn't matter which vector I multiply the scalar by. So I can multiply the first vector by a scalar, then take the dot product, or I can multiply the second vector by a scalar and then take the dot product. Doesn't matter. I will get the same result. Okay. Now here at the end is where things really get a little strange. If I take the dot product between a vector with itself, it's going to be greater than or equal to 0. And the dot product is equal to 0 if and only if the original vector is equal to 0. Now actually that's one that is familiar with math, although we don't usually think of it. But if I square a number, if I multiply just a plain old ordinary number with itself, it will be bigger than 0 unless it is 0. Okay, we're saying that same property holds with vectors and the dot product. Okay, and then this one is different. The norm of a vector squared is the vector dotted with itself. Okay, so for the most part, the dot product is going to feel a lot like a normal multiplication operation in that the properties that we're used to still hold, with one big exception. There's one that's missing here. There is no division with dot products. You cannot divide by a vector. If I take u dot v and get, I don't know, 3, I can't then go, oh, well, I wonder what v was. Let's divide both sides by vector u and then say, oh, v is just 3 over vector u. We can't do that. That makes no sense because division by vectors is not defined. Okay, you cannot divide by a vector. There is no inverse to the dot product.